Two quick announcements. Tomorrow, after the quiz has just 3 sections. It's 1 sheet of paper, front and back. Depending how quickly and easily you are able to do the law of sines and cosines questions, you might have time to do a retake, okay, during that time. You are welcome to, if it is up here and ready to go. So if you want to do a retake tomorrow, after you finish your quiz, you need to let me know by today, and you need to have all the stuff turned in when you go to do it tomorrow. All right, the other announcement would be that I would put my calculator in degree mode for this quiz. There are inverse trig questions on here, but those aren't calculator questions anyway. They're using your unit circle, which you will get. Any questions? You will have a reference sheet. So what do you have to have memorized though? Yes. So what is the law of cosines? Whatever we start with. BC cosine of the angle. Okay, you can use whatever letters you want, but it should look something like that. And the law of sines?
Sine of A over sine of A is equal to sine of B over B.
Any questions, some form of that you're comfortable with? All right, the area formulas are, this says area, read directions carefully or the quiz will not go well, okay? It says show work, label your answer, round to the nearest tenth, all that's in the directions. Most important, you're finding area. This will be on the back of your reference sheet, so you will have the formulas. Please use the appropriate one, or you'll spend a lot of time doing extra work. X, Y, Z. Side Z is 14, side Y is 6, angle X is 60. What can we do there? We're supposed to be finding the area.
Oh, the area. 0.5 times A, B.
It looks like that. So it's 2 sides and the sine of the angle included. So for our picture here, we have a 1/2, a 14, and a 6, and a sine of 60. So make sure you're in degrees and type that in. Can't stress enough that you should be typing today, because if something isn't working, we need to know about it. Anybody get an answer? And the label? These were miles, so this is square miles, right? All right, number 2. I think I'm going to wish I had on a bigger space, so let me quickly snip this and send it to a new page. All right, so it says we have some triangle, guys, and I also can't stress enough, draw the triangles, because that will help you figure out if things make sense. TRS, now I'm not drawing them proportionally. R is 15.6, S is 9, and T is 10. Okay, what formula are we going to use for this guy?
The Corral something.
How about Heron's formula, the one that's, okay.
Sure, that's
So S is 1/2 of the perimeter, whoops. And I'm going to store that into X, because then when I go to find the area,
X, parentheses, X minus, parentheses, X minus 10, X minus.
okay? All right, so we had a 15.6, a 9, and a 10, right? So the total perimeter was 34.6 divided by 2 is 17.3. I'm storing mine into X so that I can then take the square root of X times X minus 15.6 X minus 9 and X minus 10. You are certainly welcome to type it all out. I got 42.2. Anybody?
Yes.
And label? Now, I understand if you, please don't round S, okay? Because it's way too important. The semi-perimeter you're going to use 4 more times, right? If you round it, you're going to have a mess. But if you had done all this and rounded a little bit and then taken the square root, oh my goodness, you might have got just a slightly different answer here, okay? So show some work and you should be fine if your decimal is off. Okay, now reading directions again. It says, find each measurement, round your answer to the nearest tenth, show work, and label your answer. It's possible for the triangle to not exist or have more than one answer. Okay, this says find the measure of angle E. So this is what I want to find, and my label is going to be degrees. How do I set that up? It's going to be your challenge is figuring out how to get started on these. Okay? And it's law of cosines, and let's see, what is that E? So if I wanted to write it out, I'd have had E squared equals F squared plus D squared minus 2FD cosine of E. So what would I put in? And I don't care if you didn't write that out on your paper. Nope. If we're finding, well, maybe you're starting over here, I don't know. But if we're finding E, it would be 21 squared equals, and then the 26 squared and 28 squared minus 2 times what? 26 times 28 times the cosine of, and we're trying to find E. Now what? Because this doesn't go well. Now left, we have a negative 2 times 26 times 28 times the cosine of E. So we need to divide by all of that. Divide that up. Okay. When people do these wrong and do crazy stuff that I have never once demonstrated in class, I just don't even know what to write for the feedback, you know, like, I just want to put question mark. Did I teach that? I don't know. So please practice with us. 21 squared minus 26 squared minus 28 squared. I'm going to write that number down just so I show a little more work. If you don't, it's okay. Just, you got to have a lot of parentheses if you do it all at once. The bottom is negative 2 times 26 times 28. Now, what's going on because I have 2 negatives? Did someone else get 2 negatives for the top and the bottom? If you divide those, first of all, it's going to come out positive, right? I got, and again, you don't need to show all this work, but I got 0.69986, etc. Then we still have to do what? Second cosine, and you could certainly get a more exact answer by using the fraction. But I have 45.6, anybody? You might get a slightly different decimal depending where you round it, if you round it along the way. As long as I can follow your work, we should be good. What's wrong? Oh, You have plenty of time tomorrow. Do some of these twice if you need to, make sure you don't make silly mistakes, because I do the same thing, you know. It says cosine and I'll do sine, and that's gonna give you a totally wrong answer, and I'm not gonna know how, but I can see it work, at least I know you got most of the way through. All right. AC we're supposed to find here. So this is the side we're finding, AC or side B. What can we do here? This 28 is across from 10 yards. So the sine of 127 is across from B. So we're just going to type 10 times the sine of 127 divided by the sine of 28. Do we need to look at two solutions or anything? When do we look for two solutions? Yeah, if you're pushing second sine or finding an angle, you can never have two solutions for a side. What'd you get, guys? 17.0 or something? Yeah, I don't know, depends. Yards, right? Any questions? All right, number 5, KHP. Somehow K is 154 degrees, P is 22, and K is 10. Law of sines. (22) sine of 154 divided by 10. And then you do second sine of that, and you get what? 70, I got 74.7, but again, it depends how you rounded. And we did second sine, so it could also be 180 minus that answer, in theory. 105.3. Okay. This is a very rare bird. Does the 105 work? Does the 74.7 work? Also no, because there's a 154. Yesterday, this problem was giving me heart attacks because usually when it doesn't make a triangle at all, it's because you try to do the inverse sine of like 1 point something and it doesn't work and it gives you domain error. So I was like, well, how are we supposed to know this doesn't work? I just realized right now when I was drawing it, was there any possibility it was going to work? Can we have a 10 across from a 154 and a 22 across from something else? No. This would have had to be bigger than 154, right, for that to work? It's okay that we didn't notice. I think the one tomorrow on the quiz, if there's one that doesn't work at all, I'm not sure there is, but if there's one that doesn't work at all, you'll figure it out. It'll probably be easier than this, but somewhere along the line, you need to figure out that this is not possible either. So it's not possible to have such a triangle at all. If there's a not possible on the quiz, I think it's much more straightforward, okay? Likewise, this number 6 is kind of complicated, I think, and more straightforward tomorrow. All right, ABC, angle A is 63 degrees, side C is 35 kilometers, side A is 34 kilometers, angle B is what we're trying to find. Can we find angle B? Not yet. What are we going to have to find first? Angle C first? Okay, angle C. So we're going to have the sine of C is across from 35 as the sine of 63 is across from 34. Don't do the Hofbauer method and put a side length in for an angle or an angle in for a side. Be real careful with that. If I type this, I have 35 times the sine of 63 divided by 34. 0.9172, and I'm supposed to second sign that, or inverse sign. I got 66.5, or 180 minus that is 113.5. Okay, can we eliminate either of those? We're talking about C now. Should be greater than 63 degrees. Does 113 and 63 make more than 180? No. So C could be either of those, but is C what we were even trying to find? And this is where this is harder than the quiz tomorrow. I would have just asked you to find C. But we're finding B. Any ideas how we can find angle B? Yeah, we're going to have to pretend if there's a 63 and a 66.5, then what would angle B be? Or if there's a 113 and a 63, then what would angle be? Okay, we got two separate possibilities. So 180 minus 63 and minus 66.5. Say that again? I understand, but you have to list it. Unfortunately, it is physically possible for it to be that. So B could be 50.5, I got from this one, or it could be 3.5. Did anybody get that one when you do this one? Yes, it is very slim that we would even be able to draw that accurately, but it physically can happen, so we have to include it. I think the one tomorrow is much more reasonable. Yes.
It would be more likely to be 66 because there's only 35 and 34.
Yeah, it's possible to be either one. That's the issue. So, all right, number 7. ABC. Side A is 29.3 feet. Angle B is 97.4 degrees. Side C is 24.8 feet. We want to find side B over here. Anybody? Can we use law of sines? No, we need to find side B. So what do we got to put in? A disgusting number of decimals, right? Minus 2 that came with the formula. So I would type this one in and then take a minute to proofread that you have it typed right. There's a lot of garbage there. And remember, you don't want to hit any enter, at any point along the way. You want to type the whole thing in. Anybody get 1660.7? No? I can try it again. 29.3 squared is 24.8 squared minus 2 times 29.3 times 24.8 times cosine 97.4. I got this. They may need me to help them figure out what they're typing wrong. Are you not getting it?
Yeah, I'm just following this like dyslexic. Probably just got a number switched around.
This one should be minus.
Anybody else having trouble? All right, is that the answer? No, we still got square roots. I got 40.75, 40.8, and again, that would depend how you round it. If you ended up with 40.7, it's totally okay. That was a side, right? So it's feet. Side B equals. These should all have labels tomorrow, it says in the directions. Are we good? All right, then the section on applications. It says a baseball field is determined by a square with 90 feet long. The diagram H is home plate. F is first base. Suppose the first baseman ran in a straight line from F. He was standing at first base and he ran over to catch a pop-up at B. The pop-up was 120 feet from home plate. Somehow they knew the angle was 10 degrees. So how far did he run from here to here? What would we have to do there? Okay, what's across from each other so we can do law of sines? I don't think we have anything across from each other, do we? We have a 90, a 120, a 10 degrees, and we want this side. Same question we just did, right? X squared equals 90 squared plus 120 squared minus 2 times 90 times 120 times the cosine of 10 degrees. Anybody get that? 1228. And we got a square root. So I got about 35 feet. Anybody? Okay. Anybody having trouble getting that? Number 2, well, there is a diagram, you have to label it. On your quiz, there is at least one where you have to draw the diagram. Some students are assigned the task of measuring the distance between two trees separated by a swamp. So I'm thinking that's going to be AB, but I think they give us some more information. The students determine that the angle formed by tree A at dry point C and tree B is 27. Where are we going to put the 27? Yeah, it says A to C to B is 27. Written kind of weird. We also know that ABC, the angle at B, is 85. If A to C is 150 feet, how far apart are the trees AB? Okay, do I need to redraw that? What can we do? Yeah, they are just straight across. We don't even need to find the angle at A, right? Sine of is across from. All right, so we have 150 times the sine of 27 divided by the sine of 85. $68.4, anybody? Feet? All right. There is a question on the quiz that is very similar to this one, where it asks something about a parallelogram. If these are 18 and 26 and this angle is 39, actually I don't think the one on the quiz gives you an angle. I'll give you a little scoop here if you're listening to the video, okay? I think what it asks you to find is one of these angles, like maybe it says find X. The picture is drawn, I think. But if you could do it if you knew that was 39, because if you know this is 39, what's this one up here? 180 minus 39 is 141. So this is 141 degrees. I want that angle there at theta. That's the worst theta ever, but that was 26 units on the side. And I want this little angle in here. So that's across from 18. In the same way, gonna have to find that one, right? First, yeah, this is not really the way it is on the quiz. All right. So what are we doing? This would be a law of cosines question. No, because you can't do tangent because it's not a right triangle. Okay, the one on the, let me just think about what's on the quiz. I think I give you the diagonal on the quiz. That's the issue. I know I do. Don't tell Miss Abruzzo's class that we're doing this, okay? Oh my gosh, just give up.
Why not just take
Okay.
the one there with the name?
So if I told you that the diagonal was 33 and this was 141, okay? And this side was, what did they say, 18? Now, could you find this angle up here? The sine of that is across from 18 as the sine of 141 is across from 33. Now, can that angle be obtuse, the angle at theta? No, we're doing second sine, but I don't think we're going to need two solutions. I got 20 degrees. If you did, that would be or 160, but obviously in that little triangle you can't have that. All right, anyway, that was not this question. I was trying to make up one that was similar to the quiz. All right. Oh, way to go, Hofbauer. Look, there's one that's similar to the quiz. Could I have saved a little time and effort? Anyway, do you need me to do another one or you got it? We're good? All right. That was a waste of my life. Okay. Worksheet 22, there is some extra practice on this inverse function idea. Can you grab your worksheet, actually worksheet 28. Grab worksheet 28 quickly and a unit circle. Quickly. Oh, darn it, I found it and then oh good, it didn't go away anyway. Okay, so this is what you need to be looking at, right? As we do these, anything that's an inverse sine question, you can use what two quadrants would this be? From negative pi over 2 to pi over 2? Okay, so 1 is okay, if 4 is okay, but you have to call these by their negative name, right? Tangent is the same, right? If it's a cosine, inverse cosine, it says we can use anything from 0 to pi, no renaming needed. Everybody okay with that? All right, now here's the questions that are on worksheet 28 for practice. Where is the sign? 1/2. How do I know this is a where is the sign question?
This is sign.
Because it says inverse sign, right? So yes, I know I'm not answering with I'm answering with an angle, and it needs to be in radians. Okay, so where's the sign 1/2? Pi over 6. Next one, where's the sign negative 1/2? Negative pi over 6. We cannot call that 11 pi over 6. Everybody good? Where is the cosine square root of 2 over 2? Okay. Where is the cosine negative 1/2? What? Negative 1/2. 2 pi over 3. Tangent. Okay, we hate tangent. But tangent is y over x. So in the y, there's a negative square root of 3. Where is that true? Okay, there'd be a 1. We're looking for this ordered pair so that when we put the y over the x, we get negative square root of 3 over 1. That happens down at 5 pi over 3, which we have to call. Okay, good job. Okay, this says, where is the cosine negative square root of 3 over 2? The cosine is negative square root of 3 over 2 at 5 pi over 6. And then it says, what is the sine value at 5 pi over 6? A couple of you didn't know how to do these. Yes, when I get to the 5 pi over 6, the sine value is 1/2. All right, what is the sine at pi over 6? So you go to pi over 6, the sine value is 1/2. What is the inverse sine of positive 1/2? Pi over 6. That just undid it itself. This says, what is the sine at 3 pi over 4? Square root of 2 over 2. Can you say the inverse sine of square root of 2 over 2 is 3 pi over 4? No. Arc sine, positive square root of 2 over 2, that happens at pi over 4. If you just do them in steps, you should be okay. Okay, where is the sine square root of 2 over 2? We just did that. Pi over 4. And what is the tangent of pi over 4? Well, it would be square root of 2 over square root of 2, which is 1. Okay, the tangent at 5 pi over 4. If I go to 5 pi over 4, wow. It's just a regular tangent, so I can go there. It's in a quadrant we don't use lately. But the tangent at 5 pi over 4 would be what? Negative square root of 2 over negative square root of 2 would be positive 1. Where is the tangent 1? Okay. Think carefully. Tangent, you're not at a quadrantal angle. You're not putting 0 over 1 or 1 over 0 something to get tangent. It's y over x, so you have to find where they're the same so that it could be 1. All right. Good job. Now let's do the ones that are on here, because these are the kind where you have to do what? Yes. Inverse tangent is negative. So what quadrant do I draw it in? Tangent was in quadrants 1 and 4. Where do I put those numbers? Tangent is, okay, and the angle is here, yes? Always here? Got some people put the angle in a funny place. Then I was totally confused. Opposite is 4, adjacent is 3. Which one's negative? 4, because I went down. If I do Pythagorean theorem, I get 5. Very carefully. Negative 4 squared is not negative 16, right? It's positive 16 plus 9 is 25, square root is 5. Okay, Then what do they want from this picture? This helped us draw it, and now we need the sign. So we need opposite over hypotenuse, which would be -4/5. Okay, the next example, where are we going to draw that? Why? It's positive, right? Arc sine is +3/11, opposite over hypotenuse. So now I need x squared plus 3 squared equals 11 squared. Or x squared equals 11 squared minus 3 squared, which is 121 minus 9, 112 maybe?
Yeah.
Square root of 112, I think, is 16 times something. Can you check that? 16 times 7, is that right or no?
Yeah.
Okay, so what would that simplify to? 4 square roots of 7. Now, you do have to simplify to give full credit. Is it negative? No, it's in quadrant 1. So the cosine would be, now that I've labeled this, this is adjacent over hypotenuse. So 4 square roots of 7, that's going to be a funky looking 7. Over 11. Sorry, that's a mess. Anybody lost? Okay. What quadrant do we always draw in when there's a letter? Quadrant 1. How are we going to label that triangle? Yes, this is a over 1. The inverse cosine of a over 1. That's adjacent over hypotenuse. So we have adjacent and hypotenuse. If we do Pythagorean theorem, we have a squared plus some leg, we don't know, squared equals 1 squared. How do we get leg squared by itself? Okay, so we'll have leg squared equals 1 squared is just 1, right? 1 minus a squared. So to find the leg, we still have to, so what are we going to write on this leg? Square root of 1 minus a squared. Do not simplify. It does not simplify. Okay. Then it asks, once you've got that drawn, to find the tangent. The tangent of that triangle up there, which I've now made go off the screen, would be up, the angle is in here, so it's opposite over adjacent. So the square root of 1 minus a squared over a. Now can I simplify? No. Okay, I might have made one more of those up, I don't know, let's see. No, maybe not, just kidding. Do you need me to do one more of those kind? No? Okay.